Okay, hello again. So, now we're going to be working with, you know, we're given pieces of information that we might find on, our coordinate plane or graph, and we're going to use that to build some linear equations. So, here's our first problem. Find an equation whose graph is the line passing through the points -1 comma 7 and -5 comma -3. Okay, so linear equation means line, lines mean slope. So we want to use our formula for slope, which, if we cannot recall, it's m, which is our slope, is equal to y2 minus y1 over x2 minus x1. Okay, so let's look at our coordinates. All right, first one, I'm just going to say this is going to be my x1, and this will be my y1, which means our next coordinate, this will be my x2, and this one will be my y2. And then we'll just plug stuff into our formula. So y2 minus y1, -3, minus our y1, which is 7. We got x2 minus x1. x2 is -5. -5. Minus, now be careful with all these negatives. It's x2 minus x1. Our x1 is -1, so I have to subtract -1. Many students will see, okay, my x1 is -1, so I'll just write -5 minus 1. But you have to include that original negative in our formula because x1 is -1 itself. We're subtracting x1. So include the -1 when you're doing it. Okay, now to find the slope, all we gotta do is just simplify. So -3 over -7, that is -10. And -5 minus -1, two negatives will get you a positive, so it's really -5 plus 1, which is -4, which we can reduce down. Again, two negatives will become positive. We can cancel this out, and we'll get 5 over 2. So our slope is 5 over 2. Okay, whoop-de-doo. So now I know the slope to the line, but what's the equation to the line? Well, if we kind of take a look back at our slope formula, I know my m is now 5 over 2. And if I'm going to write a nice linear equation out, I need it to work for all y values and all x values. So, okay. Instead of doing y2, x2, y1, x1, whatever, I'm just going to say we're going to have a y value and an x value. I don't know exactly what those values are, but they're going to represent the x and y values that could be on our linear equation. And then, since I know that this slope of 5 over 2 is the slope that passes through these 2 points, right? That's what we did in this first half of the problem. I found the slope that passes through our 2 points, -1, 7, and -5, comma -3. What I can do from here is just take one of those points. It doesn't really matter which one. You'll get the same answer regardless. But what I'm going to do is I'll pick the first one, -1, comma 7. And I'm going to plug those values back into the slope formula. So we have y minus, I'm going to pick 7 because it's the y value of this coordinate. And then x minus the x value in that coordinate. So that's -1. And again, the whole reason I'm doing that is because I already know that this slope of 5 over 2 passes through these 2 points we want. Now I just got to set it up in such a way that my equation keeps the variable x and the variable y just like generalized. I don't plug specific values in, because if I plug a specific value in, it would cease to be an equation. All right, so now what do we do from here? Well, this is going to be, I mean, it depends on, how comfortable you are with your algebra skills, but what I'm going to do is just multiply the denominator on the right hand side on both sides of the equation. What I do to one side, I'm going to do to the other. So I'm going to multiply both sides by this denominator of x minus -1. Let's see if I can actually... I didn't really give myself enough room. Here we go. So on the right hand side, I'm going to multiply by x minus -1. And what I do to the right, I am also going to have to do to the left. So x minus -1, multiplying over here. Okay, and the whole reason I'm doing that is because when I multiply by the denominator, it's going to cancel all that out. And what I'm left with is, I'm just going to rewrite the left-hand side a little bit so it looks nicer. We have 5/2, our slope. These double parentheses look a little weird, so I'm going to use brackets. X minus -1 times our slope of 5/2 is equal to y minus 7. And really, that's an equation. We have an equation. We have a relation between our two different variables. This is a perfectly fine equation we can work with. Don't get confused by those brackets. The brackets are the same thing as parentheses. I just did it so it wouldn't look like a mess like it does over here. So what this is an example of is something called point slope form of a linear equation. And it's just a consequence of the slope formula we started out with. So the way point slope form works is it's y, your general y minus y1, equals your slope times your general x minus x1. And I mean, all this is you take the formula for slope, m equals y, I'm not going to write the y2, I'm just going to write y minus y1 over x minus x1. And again, if I multiply the denominator like I did 2 seconds ago, like I did over here, then multiplying by the denominator would get me, m times x minus x1 equals y minus y1. That's all point slope form is just you take the slope formula and multiply both sides by your denominator, x minus x1. So that is the answer. That's the type of answer we got with this problem. Find the equation whose graph is the line passing through the points -1, 7 and -5, -3. Well, that equation in point slope form is this: 5/2 times x minus -1 equals y minus 7. That's our point slope form. Now I guess I'll write it again over here. And this is the answer to that last problem. 5/2 times x minus, and remember x1 was -1. There I go, right into parentheses again, whatever. And then y minus 7. That was our point slope form answer. So this is a perfectly fine linear equation that passes through both of those points we wanted. -1, 7 and -5, -3. But point slope form is a little like meh. So sometimes we write these equations in what's called standard form. So standard form is real nice, compact, easy to look at and work with. It goes like this. Standard form of a linear equation is ax plus by equals c, where a, b, and c are integers. A should be positive. It's just one of those rules. And a, b, and c have no common factors. So we'll see what that looks like, because I'm going to convert our answer in the standard form anyway. All right. So again, let's convert that original answer we had. What was it? It was like y minus 7 equals 5 halves times x minus negative 1. Just like that. That's our point slope form. Now I want it to convert to standard form to see what that looks like. Well, let's just simplify a little bit. This x minus negative 1 is killing me. So let's simplify that to, we'll solve y minus 7, 5 halves times x plus 1. Because those double negatives become positive. We got parentheses. That value on the outside parentheses I can distribute over. So I'm going to times x with 5 over 2 and times 1 with 5 over 2. And we're going to get y minus 7 equals 5 over 2x plus 5 over 2. Okay. That's still not standard form because we want integers. We would like integers. So how can I get rid of these non-integers? How can I get rid of the fractions? Well, they all have a common denominator of 2. So what would happen? I'm just going to multiply all this by 2. And what I do to the one side, I'm going to have to do to the other as well. So times everything by 2. And when we do that, we will get, well, 2 times y is 2y. 2 times negative 7 is negative 14. Equals 2 times 5 over 2x is just 5x. And plus 2 times, well, we already did that. 2 times 5 over 2, which is just 5. All right, so we're getting closer and closer to standard form. Now I want to move my terms without the variable x or y on one side. So I'm going to do that by subtracting 5 on both sides. So minus 5, minus 5. When we do that, we get 2y minus 19 is equal to 5x. Okay, I'm just going to rewrite that over here. I know my drawing isn't the best, but, you know, it is what it is. So we got 2y minus 19 is equal to 5x. So almost there. Now I just got to move my y term over by subtracting 2y on both sides. So our final equation is going to be, that cancels out. We get negative 19 equals 5x minus 2y. And that right there in red is our standard form. This is, our ax plus by is equal to c, where a is our positive integer. So this would be our answer in standard form to that original problem. What line crosses through the coordinates negative 1, 7 and negative 5, negative 3. And in addition, let's see if I know how to do this. Here. There's a way to check your answer. So I got my standard form equation. You can also check your answer with with the point slope form, but it's kind of easy just to do a standard form. So 5x minus 2y. The 2 points we wanted to go through were -1, 7, and -5, 3. -5, -3. That was the original problem all the way back here. So let's just throw some of those values into our equation, see if stuff works out. So I'll start with the first one here. We got -19 equals 5 times -1, our x value, minus 2 times our y value of 7. So -5 times 1 is -5. -2 times 7 is -14. And yeah, that is definitely equal to -19. Everything works out. So, hey, I know this coordinate is good to go. And again, go ahead, leave it as an exercise to the viewer. Check this on your own. Plug this coordinate back into our original equation, and you'll see you get a valid answer to it. All right, hopefully that wasn't too confusing or anything. We basically covered 2 different ways to write a linear equation. We got standard form, which is, this one in red right here. That -19 equals 5x minus 2y. That's our standard form of our linear equation. And we also wrote our answer in point slope form. That was at 5/2 times x minus -1 equals y minus 7. Both have their advantages and disadvantages. We'll see how we can sort of use that stuff down the road. But we'll wait for another video because I think this one's a little bit long. Yeah, so hope you enjoyed the video. Smash that like button, hit subscribe, donate to the Patreon and all that. And I'll see you next time.